everybody, and welcome to the second video on the straight line graph. In this video, we're having a look at the gradient. So the gradient in the equation y is equal to mx plus c is the coefficient of xm. Please note that it is only the coefficient in standard form. So standard form is when y is the subject of the equation. So the gradient or slope can be interpreted in many different ways. So the first way to get the gradient is by looking at the coefficient of x. And say, for example, that you have two coordinates, you could calculate the gradient by using this gradient formula. So the gradient of AB, the line AB with points AB, is YA minus YB over XA minus XB. Now, would it make a difference if you said YB minus XA over XB minus XA? No, it wouldn't, as long as you're consistent with the one that you are starting with. So you can get your gradient either by looking at the straight line graph equation or by calculating it given 2 points. So let's have a look at the different ways that we can interpret the gradient. So first of all, if you have a gradient that is positive or greater than 0, then what you can expect is an increasing graph. So it slopes in this direction over here. If your gradient is less than 0 or negative, then you have a negative or decreasing sloping graph. So then it goes in this direction here. There are two other cases that when your gradient is equal to 0, then what you have is just a horizontal line. And when your gradient is undefined, then you have a vertical line. So those are the different options or the way that we can interpret our gradient. Another thing that we can interpret about the gradient is how big it is, the number. So if the number is very big, let's say 100, then our line is steep. So the bigger the gradient, the steeper it is. And the smaller the gradient, so let's say a half, then we can expect a flatter graph. So the smaller the gradient, the closer it is getting to 0. And that means the flatter it is going to look. The bigger the gradient, the closer it is getting to infinity, and the more vertical it will look. So those are the different ways that you can interpret the gradient. Another important aspect of the gradient is that it tells us the relationship between parallel and perpendicular lines. If lines are parallel, if line AB is parallel to CD, then what we find is that the gradient of AB is equal to CD. So if you have lines with equal gradients, what you then know is that the lines are parallel. The other bit of information is if lines are perpendicular, so AB is perpendicular to CD, then what we have is that the product of the gradients is equal to -1. So how do we get, so in other words, they are reciprocal negative inverse of each other. So how do you get the perpendicular gradient? We normally swap the fraction around and change the sign. So let us have a look at a few examples. Please pause this video now and attempt it by yourself, and then continue so that we unpause it so we can mark it together. So let us have a look through it. So we have to find the gradient in the following cases. The first case is that it is a line going through 3 and 0 and E, which is 6 and 1. So what we can do in the first case is we can calculate the gradient using the gradient formula. So our formula is the gradient of CE is equal to we start as Y. So YC minus YE over XC minus XE. So then calculating this, the YC coordinate is 0, minus, and YE is 1, so you must be careful, the minus 1. And in the denominator, we then have 3 minus 6. So if we then calculate this, then we're going to get minus 1, which is 1, over 3 minus 6, which is -3. So that is our gradient. It's a negative gradient. So let's have a look at the second one. It's parallel to this line here. So if we have the equation of the line, that means that we can see the gradient. We must check though that it is in standard form. So having a look at this, it is in standard form. Y is the subject, so then the gradient would simply be the coefficient of x. So the gradient of this line over here is m is equal to 3. Therefore, the gradient of a line parallel to it would be equal. So that means the gradient is also 3. So let us have a look at the third one. So for the third one, we have that we have to first convert it into standard form. So we have 3y is equal to 6x minus 10. To convert it into standard form, we make y the subject. So we get y is equal to, we're dividing everything by 3. So 6x divided by 3 is 2x, and 10 is minus 10 over 3. Now that it is in standard form, we can read what the gradient is. The gradient is 2. 2 can be written as 2 over 1. So what is the gradient perpendicular to it equal to? I said swap the fraction around, so 2 over 1 becomes 1 over 2, and change the sign. So this was positive, so the perpendicular gradient will be minus a half. Let's do a check to see that that method worked out. So perpendicular gradients, when you multiply them, they should be equal to minus 1. So the original gradient is 2, and the perpendicular gradient that we found is a half. And if we multiply that, we do get minus 1, which that shows that it is perpendicular.